All right, so this is the video for this week. So what we have here is the arithmetic mean of two distinct positive integers x and y. So we can say x plus y over 2, that's the arithmetic mean, is a two-digit integer, which we can call 10a plus b. And the geometric mean of two integers is x, y. And then that's the reverse. So that'd be 10b plus a. And so we want to find the absolute value of x minus y. So, well, first off, we see this radical and we don't really like it, so we should square it. And so we'll square both equations. So we have 100a squared plus b squared plus 20ab equals x squared plus 2xy plus y squared over 4. And for the other equation, we just have, well, xy and 100b squared. Let me write it a different way. Okay, so a squared plus 100b squared and plus 20ab. Okay, so if we subtract this one to this one, what we get is x squared minus 2xy plus y squared over 4 equals, and then for this one minus this one, we have 99a squared minus 99b squared, and that's it. So if we factor this, we can have 99a squared minus b squared. And so this is all a square. So what we see is this side, it becomes x minus y over 2 squared. And so this goes to here, and then this goes to here. So if we take the square root of both sides, then if we basically take we only want this part, right? So if we were to take the square root of both sides, we would have x minus y over 2 equals square root of 99 a squared minus b squared. Because x and y are symmetric, so we can just say that x is greater than y. And then if we multiply by, and then we have to multiply that by 2. So 2, and then we take out the 9, so times 3, 11, a squared minus b squared. And what we know is that this has to be an integer. X minus y, it has to be an integer. So we see, in order for the inside here to become an integer, it needs to be a square. Oh, the reason why it has to be an integer is because x and y are both integers, so it just has to be an integer. Okay, so we'll take a look at this part. So square root of 11 times a squared minus b squared. In order for this to become a square, in order for this to become an integer, in other words, the inside part is a square, a squared minus b squared has to be 11 times something, because yeah, because it needs to become like square. So we know that a is a digit because that's the definition that we gave it. It's a two-digit number, so a has to be the first digit. So it has to be a digit, which is always less than 10. So a can at most be 9. So a can at most be 9. So we have to say, a squared minus b squared equals 11n. And all right, I'll scroll down. So because a has to be at most 9, then a squared, it would be 81. And so 81, if you think like um if you think about squares, like if you just run through a list of squares, for b, then n would have to be 1 or 4. So we'll just go through both the cases. So if we go through 1, what we have is x minus y equals, so that would be 66. And if n equals 4, that would be 132. And that's clearly impossible because it needs to be a 2-digit integer for the sum, so the difference can't be a 3-digit integer. So therefore the answer would be 66.